Hi friends, here something for the hardware section. You sure all know the zero voltage switching circuit. I refer to the auto-resonant one. There are many images, schematics and videos on the internet about this. The schematic is like the following one. I have tried several experiments and things with this circuit and had some issues. While it works fairly good at given values, if you always use the same inductance, the same capacitors, keeping within the voltage range, they work fairly well. But as I'm always doing experiments, changing everything, trying new things, I always had problems with this circuit. Mostly the body diodes of the MOSFET getting fried, some resistors for the gate driving fried, and so on. I had several fried parts and transistors and all this, and I could find the problem is a very poor switching in this circuit. You know, usually the MOSFET is driven with dedicated drivers, which outputs a good amount of current, of amperes, for a very short time, but the current has to be significant to have a good switching on the MOSFET. So I thought about how to improve this circuit and get to the following solution. Here is a schematic about my current version, which works very fine. There is also another advantage of this circuit, that you can work mostly the resonance systems without a capacitor, also using the distributed capacitance of the coils or of the transformer which you are driving, which is a great advantage because you can drive it longitudinally instead of LCR resonant. So here I will show you some of my buildings. They are 3D. This is the first one. It's built without PCB, as you can see, as a fast solution. The transistors here, the MOSFETs, are BUZ91. I think it's 500 or 600 volts and 6 ampere, like something like this, which give it a good output. I have implemented the totem pole configuration of a NPN and a PNP transistor, protection diodes. On the other side the same. Here a voltage regulator with a high voltage transistor, so I can go up with the voltage about 40-50 volts or more if needed, and if the circuit supports it, of course. In this configuration I use 2 inductors, and so I can drive a single coil, but it can be changed for the version with 1 coil and the center tap also. Then here is a little bit bigger version with silicon carbide MOSFETs. The other thing I changed, as you can see in the schematic, is the diode, the blocking diode, to cancel out the body diode of the transistor, which was one of the issues that I had before. Here also these are of course fast diodes, ultra fast diodes, and yeah. So I will show you one of these modules working with a high voltage transformer. So as you can see, I put no capacitor on the primary side as it is usual used in the zero voltage switching circuit. This transformer is designed as a flyback transformer. It has not too much turns on the secondary, therefore. The power supply goes into current protection mode, yeah, it works really fine, and as I told you, it's a very great advantage that you can couple directly to the self-capacitance of the system. So for example, if you put some bigger objects as electrodes or some plates, the frequency will go down and it will couple directly to the resonant frequency of the whole transformer system. I hope this will be useful for some implementation.